Hey Math 206 students, last time we had side, side, side congruence and side, angle, side. This one will be hypotenuse leg, which is only a congruence condition for right triangles. So that's hypotenuse leg. It happens if the hypotenuse, which is the side across from the right angle, and one leg of one right triangle are congruent to the hypotenuse and leg of another right triangle, then you get that the triangles are congruent for free. Notice that this is almost like side-side angle, where the angle's not included between the sides, except that's not really a congruence condition for all triangles. It's only when that angle is a 90-degree angle. So let me show you an example of why that doesn't work. Here is an example of two triangles that you can create that with a given two sides and a given angle here that are not congruent to each other, ABD and ABC. So notice that that angle A is congruent to angle A, and side AB is congruent to side AB, and also that BD is congruent to side BC because they're both radii in the same circle. But so we have angle and side and then another side. But these two triangles, ADB, is not congruent to triangle ACB. All right. So therefore, side-side angle is not a congruence property unless the angle is a right angle. And then we don't call it side-side angle, we call it hypotenuse leg. All right. All right, so now let's go through a few selected triangle properties. First, any point that's equidistant from the endpoints of a segment is on the perpendicular bisector of the segment. So what that means is you're given a segment here. Suppose you have a point here that's the same distance from one endpoint as the other. That point happens to be on what's called the perpendicular bisector. Perpendicular bisector is a segment that bisects your given segment at a 90-degree angle. All right, and the other property is at any point on the perpendicular bisector, so if you have a point that happens to be on this perpendicular bisector, then it happens to be the same distance away from the two endpoints of the segment. All right, so, and we can use isosceles triangles really to make use of these properties. All right, for every isosceles triangle, number one, the angles opposite the congruent sides are congruent. So that's the two, we usually call those the base angles. Base angles in a isosceles triangle are congruent to each other. And also, the angle bisector of an angle formed by the two congruent sides contains an altitude of the triangle and is the perpendicular bisector of the third side of the triangle. So we'll see that in our next construction. First of all, what is an altitude? Well, the altitude of a triangle is a perpendicular segment from the vertex of the triangle to the lines containing the opposite side of the triangle. So here's what that looks like. Here's one triangle, ABC. If you can imagine, I'm not going to construct it, I'll just imagine what it looks like, drawing in a line emanating from vertex B down to the opposite side that meets it in a right angle. That's an altitude. You can also draw the altitude from vertex A, and we'll find a way to construct these altitudes. And there's also an altitude from vertex C. So again, it's just a line segment coming from the vertex to the opposite side. The reason that I said it goes to the lines containing the opposite side of the triangle, here the altitude actually touched the side of the triangle, but if you had an obtuse triangle, then some of these altitudes actually don't intersect the opposite side of the triangle. So for example, if you drew any line segment you draw from A to the opposite side, BC, you will not be able to draw a perpendicular segment emanating from A. So in this case, what you do is you draw in an extension of the side BC so that it's past vertex B. And then you can drop down the altitude. You see that it will intersect the line containing the side BC. All right, so let us construct perpendicular bisectors. Basically what I'm going to be doing in order to construct a perpendicular bisector is I'll draw in two isosceles triangles where AB is the base of that triangle. So imagine that AB is one side of the triangle. I'll draw another side of the triangle, or I'll set my compass to a certain length, and I'll go ahead and make an arc coming out from side A, and this will denote all of the points that are a certain distance away from vertex A, and then I'll move it over to vertex B without changing this distance here. And I'll draw in an arc which represents all the points that are the same distance away from vertex B. Now where these two arcs intersect, let's call them P and Q. Basically what you have is a triangle above my line segment and a triangle below my line segment. And both of these triangles are isosceles triangles because I already said that this distance and this distance here are the same. So there's an isosceles triangle, here's another isosceles triangle. So what I know is that this point is equidistant from the two ends of my segment, same distance to A, same distance to B. So this point must be on the perpendicular bisector of the segment. Also, this point Q is the same distance from A as it is to B. So Q has to also be on the perpendicular bisector of the segment. Therefore, P and Q are both on the perpendicular bisector. So then I can construct the perpendicular bisector by connecting those 2 points. So there's my perpendicular bisector. The other way I can do this, I'm going to give you another construction. Suppose that I didn't have enough room on my paper to draw this arc all the way above and all the way below my line segment. Let me draw in another line segment. Call it AB. And instead of drawing an isosceles triangle above and below the given line segment, I'll draw two different isosceles triangles basically above the line segment. So I'll set my compass so that it's a little bit more than halfway from A to B, and I will draw an arc emanating from A, same distance, draw another arc emanating from B. That'll give me my first intersection point P. That's the same distance away from A as from B. Now take your compass and open it up a little bit more. Just make it a little bit wider. And I'll draw a new arc emanating from A. Same distance, new arc emanating from B. See, that gives me a second intersection point Q. That's the same distance away from A as it is from B. All right, these 2 points again are equidistant to the endpoints of the segment. Therefore, they are both on the perpendicular bisector. So I can just connect the dots, and I get for free that a perpendicular bisector to the given segment.